What if everything you think you know about yourself, your memories, your sense of identity, even the world around you, is nothing more than a fleeting blip in the vast emptiness of space? Picture this: you're not a person with a past or a future, but a momentary flicker of thought, a random fluctuation in the cosmic void. It sounds like science fiction, but this bizarre idea isn't just the stuff of imagination. It's a real theoretical puzzle called the Boltzmann Brain, and it forces us to ask one of the most unsettling questions in physics. Are we even real, or are we just accidental ripples in an infinite universe? Think about the last time you woke up from a dream so vivid it took a second to remember who you were. Now, stretch that feeling across existence itself. The Boltzmann Brain theory suggests that in an infinite universe, given enough time, random particles could spontaneously arrange themselves into a fully formed consciousness, complete with false memories of an entire life. You could be one of those temporary minds, experiencing a phantom reality that vanishes as quickly as it appeared. It's a thought experiment that blurs the line between philosophy and physics, challenging not just what we know about the cosmos, but what it means to be alive at all. So why does this matter? Because if there's even a sliver of a chance that we're just cosmic accidents, it changes everything. It forces us to confront the fragility of our existence and the eerie possibility that the universe might not care about us at all. But here's the twist: this isn't just a bleak thought experiment. It's a doorway to some of the most profound questions science can ask. Over the course of this video, we'll explore how Boltzmann brains could rewrite our understanding of reality, why some physicists take them seriously, and what it all means for the way we see ourselves in the grand scheme of things. Strap in, because this journey is going to bend your mind in ways you never expected. To understand how something as unsettling as a Boltzmann brain could even be possible, we have to go back to a deceptively simple idea from the 19th century: entropy. Ludwig Boltzmann, a physicist obsessed with how disorder unfolds in the universe, introduced a radical concept: given enough time, even the most unlikely events become inevitable. Imagine a box of gas particles bouncing around. Left to themselves, they'll spread out evenly. That's high entropy, the natural state of maximum chaos. But Boltzmann realized that if you wait long enough, sheer randomness could, by pure chance, arrange those particles into a fleeting moment of order, like all the air molecules in a room suddenly clustering in one corner. Now take that same logic and expand it across the entire cosmos. In an infinite universe with infinite time, even the most improbable arrangements of matter become not just possible, but statistically unavoidable. That's where Boltzmann brains come in. If a random clump of particles can briefly form a structured system, why not a self-aware mind? Not a brain born from evolution, but one that flickers into existence complete with fabricated memories, a phantom life story, and the unshakable belief that it's real. The terrifying beauty of this idea is that it doesn't require any grand design, just the cold mathematics of probability playing out over cosmic timescales. What makes this more than just a wild thought experiment is its connection to modern cosmology. Boltzmann's ideas about entropy and time underpin how we understand the arrow of the universe, why we remember the past but not the future, why stars burn out, and why disorder increases over time. But if the universe truly is eternal, or if multiple universes exist in an endless multiverse, then Boltzmann brains stop being a quirky hypothetical and start looking like an inevitability. After all, if randomness can produce a fully formed conscious experience once, why wouldn't it happen an infinite number of times? That's the unsettling paradox at the heart of this. The more we learn about the universe's vastness, the more plausible it becomes that we might just be statistical noise in the void. If Boltzmann brains are possible, then everything you think you know could be an illusion. Here's why that's so destabilizing. In an eternal universe, random fluctuations would eventually produce far more disembodied, momentary minds than real, biologically evolved brains like ours. Imagine flipping a coin forever given infinite time. You'd eventually get a sequence of 1,000 heads in a row. Now replace coins with particles and heads with consciousness. Statistically, false minds with fake memories would vastly outnumber real ones. That means the odds are staggeringly high that you're not an actual person with a real past, but a fleeting accident, a cosmic glitch hallucinating an entire lifetime in an instant. This isn't just about physics, it's an existential earthquake. Your memories, relationships, even the sensation of reading these words right now could be a mirage conjured by chaos. The past you remember might never have happened. The future you plan may never arrive. Philosophers call this the problem of deception. Normally, we trust our perceptions because evolution hardwired us to interpret reality accurately. But a Boltzmann brain has no evolutionary history. It's a rogue thought with no anchor in truth. So how do you prove you're not one? Every piece of evidence you'd use, your childhood photos, scientific laws, even the feeling of your own heartbeat, could just be part of the illusion. Some physicists dismiss this as a paradox too absurd to take seriously. After all, if Boltzmann brains dominate the cosmos, why do we observe such an orderly universe? Shouldn't reality be a soup of fractured consciousnesses popping in and out of existence? Yet the eerie truth is that our universe's structure might actually support the idea. If space is truly infinite, or if multiple universes bubble up eternally in a multiverse, then pockets of order, like our seemingly stable cosmos, are just rare statistical blips in an ocean of randomness. We might cling to the comforting belief that we're in one of those orderly pockets, but probability says otherwise. What's fascinating is how this forces science to confront its own limits. Normally, we assume our observations reflect objective reality, but if most minds in existence are Boltzmann brains, then science itself becomes untrustworthy. The laws of physics you learned in school could be a fluke. The constants that make life possible might just be part of your temporary delusion. This isn't just speculation, it's a direct challenge to the foundation of empirical knowledge. If solipsism, the idea that only your mind is certain to exist, was the philosophical boogeyman of the past, Boltzmann brains are its hypercharged, physics-backed upgrade. Yet there's a twist that makes this more than a nihilistic thought experiment. Some researchers argue that the mere fact we're having this discussion might be evidence against the Boltzmann brain scenario. Complex, stable consciousnesses like ours require an incredibly specific set of conditions. If we were just random fluctuations, why do our memories and observations hold together so coherently? Maybe the universe has built-in mechanisms like quantum mechanics or cosmic inflation that prevent such chaotic randomness from dominating. Or perhaps reality is stranger than we think, and Boltzmann brains are a sign we're missing a deeper layer of physics altogether. Either way, this isn't just about existential dread, it's about humility. The Boltzmann brain paradox reminds us that our grasp on reality is fragile, shaped by forces we barely understand. It doesn't mean we should stop trusting our senses after all. You still have to live your life, whether it's real or not. But it does mean that when we stare into the cosmos, we're also staring into a mirror, questioning not just the nature of the universe, but the nature of our own existence within it. And that's a mystery far wilder than any fiction. To make sense of how Boltzmann brains could emerge from the void, we need to dive into the strange physics that allows order to spring from chaos. It all starts with entropy, the universe's stubborn tendency toward disorder. Picture a sandcastle on the beach. Left alone, wind and waves will scatter it into shapeless grains. That's entropy in action, systems breaking down into their most random, unorganized state. But here's the twist Ludwig Boltzmann uncovered. If you wait long enough, pure randomness can sometimes spit out order by sheer accident. Imagine a gust of wind randomly sculpting those scattered sand grains back into a perfect castle. It's astronomically unlikely, but in an infinite universe with infinite time, even the craziest flukes become inevitable. This isn't just theory, it's baked into quantum mechanics. At the tiniest scales, particles pop in and out of existence thanks to vacuum fluctuations, like cosmic dice constantly rolling in empty space. Most of the time, these fluctuations cancel each other out, but occasionally, against all odds, they align just right to create something structured like a temporary bubble of consciousness. Think of it as shaking a box of Scrabble letters forever. Eventually, they'll spell out a coherent sentence purely by chance. A Boltzmann brain is like that sentence, a fleeting arrangement of particles convinced it means something. The real kicker, our universe might be tailor-made for these freak accidents. Quantum physics tells us empty space isn't really empty. It's a seething foam of potential where particles borrow energy to exist briefly before vanishing. In this chaos, complexity can arise spontaneously. It's like a tornado assembling a watch from a junkyard. The odds are vanishingly small, but when you've got infinite tries, the impossible becomes routine. Yet there's a catch that makes Boltzmann brains even weirder. According to quantum field theory, low-energy states are far more probable than high-energy ones. So if a conscious mind did randomly form, it's far more likely to be a bare-bones awareness, a lone observer floating in darkness with fake memories, than a brain embedded in a richly detailed universe like ours. That's why some physicists argue that if Boltzmann brains dominate reality, we shouldn't see galaxies, coffee cups, or YouTube videos at all. The fact we do suggests either our universe is special or we're ignoring a deeper law of physics that prevents such chaos from taking over. This isn't just abstract noodling, it's a crisis for cosmology. If Boltzmann brains are possible, they undermine everything from the Big Bang to dark energy. Why? Because a universe that permits random consciousness also makes our apparently orderly existence statistically ludicrous. It's like winning the lottery every second for 1 billion years. Possible, technically, likely, not a chance. That's why some scientists use the Boltzmann brain paradox to test theories about the universe's end. If a model predicts an eternity of empty space, it also predicts minds spawning from the void. And that's a red flag. The math might be missing something fundamental. So where does this leave us? Wrestling with the unsettling idea that reality's rulebook might be written in probabilities, not certainties. The same physics that explains why ice melts and stars die also whispers that you could be a ghost in the cosmic machine, a hiccup in the equations. But here's the hopeful counterpunch. The fact we notice this paradox might be the very clue that saves us from it. After all, a true Boltzmann brain wouldn't have consistent laws of physics to question. Its reality would flicker and glitch. Our ability to even have this debate logically, coherently hints that we're part of something more stable than randomness. Unless, of course, that's exactly what a Boltzmann brain would tell itself. If our universe stretches on forever, branching into infinite realities or endlessly collapsing and rebirthing in a cosmic loop, then Boltzmann brains stop being theoretical oddities and start looking like cosmic certainties. Picture a library with every possible book that could ever be written. In that infinite collection, there's not just one copy of your life story, there are countless versions with slight variations, along with volumes where the text suddenly devolves into nonsense or repeats the same word endlessly. That's the multiverse in a nutshell. If space and time have no end, then every configuration of matter, no matter how improbable, must eventually happen somewhere. Including self-aware minds materializing from the chaos, fully convinced they've lived a lifetime. But here's where it gets wilder. Some cosmologists argue that if the universe cycles through endless big bangs and big crunches, a theory called the Big Bounce, then Boltzmann brains become even more likely than ordinary observers like us. Why? Because in an eternal cycle, the vast majority of time isn't spent in orderly epochs where galaxies and life can form. It's spent in the dark, chaotic stretches between cosmic rebirths where random fluctuations dominate. In that near-endless sea of disorder, the universe isn't making stars or planets. It's accidentally spitting out disembodied minds like glitches in a cosmic simulation. Yet not all physicists buy this doomsday scenario for reality. Finite universe models throw a wrench into the Boltzmann brain paradox. If space and time have hard limits, if there's only one universe with a finite lifespan and no multiverse, then the math shifts dramatically. Suddenly, the odds of particles arranging themselves into a conscious entity by pure chance plummet to practically zero. No infinite time means no infinite rolls of the dice. It's like trying to win the lottery with a single ticket instead of buying one every second for eternity. This split in cosmological theories has real stakes. If Boltzmann brains are inevitable, then our entire understanding of reality might be built on a statistical fluke. But if the universe is finite, we're back on solid ground. Our memories, science, and shared history could genuinely reflect an objective reality. The catch, proving which model is correct, is fiendishly difficult. Even if we're in a finite universe, we can't peek beyond its edges to check. And if we're in a multiverse, we'd never see the other branches. What's fascinating is how this debate exposes the limits of our cosmic intuition. We evolved to navigate a world of medium-sized objects moving at medium speeds, not to grapple with infinities or quantum randomness. That's why Boltzmann brains feel like a prank from the universe itself. They force us to admit that deep down, we might not just be in the cosmos, we might be the cosmos, briefly fooling itself into thinking it's something more. And whether that's terrifying or enlightening depends on how comfortable you are with uncertainty. At first glance, the Boltzmann brain scenario seems to demolish any confidence in our own reality. But there's a powerful counterargument lurking in the very fabric of our existence evolution. Unlike a random fluctuation, evolved brains like ours aren't accidents. They're the products of billions of years of trial and error, honed by natural selection to perceive and interact with a consistent universe. Think about it. If consciousness could just pop into existence from chaos, why don't we see disembodied minds floating around, blinking in and out like cosmic fireflies? Why is every thinking thing we've ever observed tethered to a physical body, a biological history, a lineage that traces back to the origins of life itself? This is what physicists call the problem of observers, and it's a glaring hole in the Boltzmann brain hypothesis. If random fluctuations were churning out self-aware entities left and right, the cosmos should be teeming with ghostly intelligences unmoored from time and space. Instead, every conscious being we know is rooted in a material world, shaped by the same laws of physics and chemistry. That's not just a coincidence. Evolution acts like a cosmic filter, producing observers who are reliable minds that evolved to track reality because survival depended on it. A gazelle that hallucinated predators would get eaten. A human who couldn't distinguish imagination from fact wouldn't last long. But a Boltzmann brain, it has no evolutionary stakes. Its entire existence could be a fever dream with no consequences, no selection pressure to ground it in truth. Here's where the math gets fascinating. The probability of a fully formed human brain emerging from random particle collisions is astronomically low, like shuffling a deck of cards into perfect order by throwing it in a tornado. But evolution isn't random. It's a cumulative process, building complexity step by step. The odds of life forming aren't the same as the odds of a single, finished brain materializing from the void. One is like winning the lottery with a single ticket. The other is like saving a penny a day for 1 billion years until you can buy the lottery company. Evolution works with time and compounding advantages, while Boltzmann brains rely on brute force luck. There's another layer to this, the universe's observable consistency. If most minds were Boltzmann brains, we wouldn't expect them to share the same physical laws or historical narratives. One might remember a world where gravity repels instead of attracts. Another might recall a childhood on a planet made of jelly. Yet every human culture, every scientific experiment, every scrap of recorded history points to a single, coherent reality. That's staggeringly unlikely if we're all just fluctuations. It's like a room full of strangers suddenly discovering they've all had the same dream, down to the tiniest detail. This isn't just philosophy. Modern cosmology leans heavily on something called the anthropic principle, the idea that the universe's laws must allow for observers like us to exist because, well, here we are. Boltzmann brains turn that logic upside down. If they dominate the cosmos, we shouldn't see orderly galaxies or stable atoms. We should be solitary minds drowning in noise. The fact we don't suggests either that Boltzmann brains are impossible or that our universe is far stranger than we've dared to imagine. Some theorists propose a middle ground. Maybe the conditions that allow for Boltzmann brains, like infinite time or a multiverse, also guarantee the emergence of ordered pockets where life can evolve. In that case, we're not either evolved minds or random fluctuations. We're products of a reality so vast it contains both, with ordinary brains like ours simply being the ones most likely to ask questions. It's a humbling thought. Even if the universe could spawn phantom consciousnesses, we might be the rare exceptions, real minds in a sea of fleeting illusions. So where does that leave the debate? In a way, the Boltzmann brain paradox is less about proving we're real and more about understanding how reality works. It's a stress test for our theories of the cosmos, pushing us to ask why the universe seems so finely tuned for life when randomness should dominate. Whether you find that terrifying or exhilarating, one thing's certain: the answer won't just reshape physics. It'll redefine what it means to be a thinking thing in the grand scheme of existence. Imagine waking up one day and discovering that not only is your reality an illusion, but the entire universe itself might be someone else's experiment. This is where the Boltzmann brain hypothesis collides with another mind-bending idea, Nick Bostrom's simulation theory. Both theories force us to question the nature of existence, but they do it in eerily similar ways. If random fluctuations can spawn self-aware minds, could those minds also be running inside an advanced civilization's computer simulation? It's like peeling back layers of an infinite onion, each layer revealing a new possibility that we're not what we seem. Bostrom's argument starts with a simple premise. If a civilization ever reaches the technological capability to simulate conscious beings, they'd likely create countless such simulations. Statistically, that would mean simulated minds vastly outnumber biological ones, making it overwhelmingly probable that we're in one of those simulations rather than base reality. Now swap simulation with Boltzmann brain, and the parallels become uncanny. Both scenarios suggest that most conscious experiences in the universe are fleeting, unanchored illusions, either as accidental flickers in the void or as lines of code in a cosmic program. The difference is in the origin story. One is a product of chaos, the other of design. But here's where things get slippery. If Boltzmann brains are possible, they throw a wrench into the simulation argument. Why? Because a simulated universe would need to be internally consistent to feel real. A civilization advanced enough to create such a simulation would presumably iron out glitches and contradictions to maintain the illusion. But a Boltzmann brain's reality is inherently unstable, a brief, disordered blip with no underlying rules. So if we're in a simulation, it's far more likely to be a carefully crafted one than a random fluctuation pretending to be orderly. Unless, of course, the simulation itself is a Boltzmann brain, a makeshift reality slapped together by chance, destined to dissolve as quickly as it formed. This isn't just philosophical whiplash, it's a clue. The fact that our universe operates with such precision, from the constants of physics to the reliability of memory, leans more toward the simulation hypothesis than the Boltzmann scenario. After all, chaos rarely produces the kind of coherence we take for granted every day. But there's a chilling counterpoint. What if the simulation is designed to mimic a Boltzmann brain? An advanced civilization might run experiments to see how conscious beings react to the realization that they're temporary. It's like a cosmic version of the Truman Show, where the scriptwriters deliberately introduce existential doubt to study the results. The overlap between these ideas reveals something profound about how we grapple with reality. Both theories force us to confront the limits of human cognition. We're pattern-seeking creatures wired to find meaning even in randomness. So when physics suggests that existence itself might be a statistical fluke or a digital construct, it triggers a kind of existential vertigo. But there's a silver lining. The very act of questioning whether we're Boltzmann brains or simulated beings implies a level of self-awareness that pure randomness probably wouldn't produce. A true accidental mind wouldn't waste energy doubting its own existence. It would just be like a dream you don't realize you're having. Ultimately, these thought experiments aren't just about proving or disproving our reality. They're stress tests for the boundaries of science and philosophy. Whether we're fleeting fluctuations or characters in some grand simulation, the questions we ask, and the fact we can ask them at all, might be the best evidence that we're part of something deeper. Or, at the very least, that the universe has a wicked sense of humor. Time isn't just a backdrop for the Boltzmann brain paradox, it's the fuel that makes the whole unsettling idea possible. To grasp why, think of time not as a straight line but as an endless ocean. In a finite universe with a limited lifespan, the odds of particles randomly arranging themselves into a conscious mind are practically zero. But stretch that timeline to infinity and suddenly, every improbable event becomes not just possible but unavoidable. It's like rolling a billion-sided die forever. Eventually, it'll land on the same number a billion times in a row. That's the power of eternity. Given enough of it, chaos starts to look like order. But here's the twist: modern physics suggests time might not be as fundamental as we think. Quantum gravity theories like loop quantum gravity or string theory propose that time could be an emergent property, a side effect of deeper, timeless processes, like how temperature emerges from the motion of atoms. If that's true, the Boltzmann brain paradox gets even weirder. Without time as a bedrock, the idea of waiting long enough for random fluctuations to produce consciousness breaks down. You can't have infinite time if time itself is just a makeshift illusion. Imagine building a house on what you think is solid ground, only to discover the ground is actually a trampoline. That's what happens to Boltzmann brains in an emergent time universe. Their entire premise relies on time's unlimited patience, but if time is more like a flickering shadow cast by quantum interactions, then the rules change. Suddenly, the cosmic casino where particles endlessly shuffle might not even have a clock. No infinite time means no guarantee that randomness will ever spit out a self-aware mind. This isn't just theoretical gymnastics. The nature of time shapes how we think about reality's durability. In classical physics, time is a relentless river, carving out events one after another. But in quantum gravity, it's more like a mosaic, a pattern that only makes sense when you step back. If time is emergent, then Boltzmann brains aren't just unlikely. They might be impossible because the substrate they depend on, eternity itself, could be a mirage. Yet there's another layer to this. Even if time is emergent, some models suggest that certain quantum states could still mimic infinite durations in discrete steps, like frames in a movie, creating the illusion of motion. In those cases, Boltzmann brains might not need real time, just enough computational steps to fake it. But that raises a new question. If consciousness can emerge from timeless physics, what does that say about us? Are we just temporary patterns in a quantum algorithm, mistaking mathematical regularity for the flow of time? The irony is delicious. A theory that began as a thought experiment about randomness now forces us to confront whether time itself is real. And that's the real lesson here. The Boltzmann brain paradox isn't just about minds in the void. It's a spotlight on how little we understand the stage on which existence plays out. Whether time is fundamental or emergent, infinite or illusory, one thing's clear: the universe has a way of dissolving our assumptions like sandcastles at high tide. Quantum mechanics might seem like the last place to look for answers to a paradox as bizarre as Boltzmann Brains, but the rules governing the subatomic world could actually hold the key to unraveling this cosmic riddle. At the heart of quantum theory lies a concept called decoherence, the process by which fragile quantum superpositions collapse into definite states when interacting with their environment. Picture a spinning coin. While it's in the air, it exists in a superposition of both heads and tails. The moment it lands, decoherence kicks in, forcing it to choose one outcome. Now apply that to the Boltzmann brain scenario. If a random fluctuation tried to assemble a conscious mind from quantum chaos, decoherence would act like a cosmic bouncer, breaking up unstable configurations before they could fully form. The universe, it turns out, might have built-in safeguards against rogue consciousnesses materializing from nowhere. But decoherence isn't the only quantum quirk that could slam the door on Boltzmann brains. Enter the many worlds interpretation, which suggests every quantum possibility branches off into its own parallel reality. In this view, the universe isn't a single timeline but an ever-expanding tree of alternate histories. At first glance, this seems to make Boltzmann brains more likely. After all, infinite branches mean infinite opportunities for random minds to pop up. But here's the catch: many worlds implies that observers like us only exist in branches where the laws of physics remain stable enough to support complex life. A Boltzmann brain, by contrast, would emerge in a disconnected, chaotic branch, one where the very rules needed to sustain consciousness quickly unravel. You can think of it like a defective computer program. Most branches run smoothly, but a few glitch out instantly. A Boltzmann brain would be born into one of those glitches, doomed to dissolve before it could even question its existence. This isn't just theoretical hand-waving. Quantum field theory imposes strict energy constraints on how particles can fluctuate in a vacuum. For a Boltzmann brain to form, it wouldn't just need particles to randomly align, it would need them to borrow enough energy from the vacuum to sustain coherent thought, and that energy debt would come due almost immediately. It's like trying to build a skyscraper out of smoke. The deeper you dig into quantum mechanics, the more it seems the universe is rigged against spontaneous consciousness. Even in the wildest fluctuations, there's a limit to how much complexity can emerge before the universe snaps it back into disorder. Yet the most compelling argument against Boltzmann brains might come from an unexpected corner of physics: black holes. According to the holographic principle, the information in any region of space is encoded on its boundary like a cosmic zip file. If that's true, then a Boltzmann brain, a self-contained, isolated mind, would violate the fundamental way information is allowed to exist in the universe. You can't pack an entire illusory history into a fleeting fluctuation any more than you could fit an encyclopedia into a single pixel. The math simply doesn't add up. Of course, none of this is a bulletproof refutation. Quantum mechanics is famous for defying intuition, and the line between possible and impossible is blurrier than we'd like to admit. But what's remarkable is how these theories don't just dismiss Boltzmann brains, they transform the paradox into a litmus test for our understanding of reality itself. If quantum decoherence, many worlds, or holography are correct, then the universe isn't just hostile to random minds, it's structurally incapable of sustaining them. And that's a comforting thought, unless, of course, this entire explanation is just what a Boltzmann brain would tell itself to feel real. Cosmic inflation, the theory that the universe underwent a mind-boggling exponential expansion in the first fraction of a second after the Big Bang, might be the ultimate antidote to the Boltzmann brain paradox. Picture a drop of ink in a glass of water. In a static universe, that ink might occasionally form a random pattern by chance, like a fleeting smiley face. But if you suddenly diluted that glass into a swimming pool, the odds of the ink arranging itself into anything coherent would plummet. That's what inflation does to the cosmos. By stretching space itself faster than the speed of light in those early moments, it doesn't just expand the universe, it ironed out irregularities, smoothing the primordial chaos into a near-uniform sea of matter and energy. For Boltzmann brains, this is bad news. If the universe's rapid growth dispersed fluctuations too thinly, there'd be no dense pockets of randomness left to accidentally assemble a conscious mind. Alan Guth, the physicist who pioneered inflationary theory, once described this expansion as hitting a cosmic reset button. Before inflation, the universe could have been a turbulent mess of quantum jitters, prime real estate for random fluctuations to cook up Boltzmann brains. But inflation's explosive stretching would have stretched those potential mind-forming ripples so thin that they'd effectively vanish. It's like trying to build a sandcastle with grains scattered across a desert. The raw materials are there, but they're too spread out to ever come together. Here's where it gets even more interesting. Inflation doesn't just make Boltzmann brains unlikely, it replaces them with a different kind of inevitability. In Guth's model, the same quantum fluctuations that might have formed rogue consciousnesses instead got stretched into the seeds of galaxies. Those tiny irregularities, magnified by inflation, became the gravitational blueprints for everything we see today: stars, planets, and ultimately us. So while the Boltzmann scenario imagines consciousness as a cosmic typo, inflation flips the script. We're not accidents. We're the carefully crafted consequences of physics playing out exactly as it should. But inflation isn't just a one-time fix. Some models suggest it never truly stopped, that our universe is just one bubble in an eternally inflating multiverse. If that's true, the implications for Boltzmann brains get twisty. On one hand, infinite bubbling universes mean infinite opportunities for randomness to strike. On the other, most of those bubbles would be cold, empty, and inhospitable to any form of consciousness, random or otherwise. The rare universes like ours, where inflation ended gently enough to allow structure, become the exception, not the rule. In this view, Boltzmann brains aren't just rare, they're crowded out by the sheer vastness of sterile space. Critics of this argument point out a loophole. Even in an inflating multiverse, there's always some non-zero chance for a fluctuation to beat the odds. Given eternity, shouldn't those long shots eventually hit? That's where quantum field theory steps in. The energy required to sustain a self-aware mind isn't just a matter of particle arrangement, it's about stability. A Boltzmann brain isn't just a random clump of neurons, it's a system capable of maintaining coherent information long enough to think. Inflation's aftereffects, like dark energy accelerating the universe's expansion, make that nearly impossible. The vacuum of space isn't just empty, it's actively pulling things apart. Trying to form a stable consciousness in that environment is like trying to light a match in a hurricane. What's fascinating is how this ties back to the anthropic principle. If the universe hadn't undergone inflation, Boltzmann brains might dominate. But we find ourselves in a reality where inflation happened, galaxies formed, and life emerged precisely because those conditions are the only ones where observers like us can exist to ask the question. It's a self-correcting loop. The physics that makes us possible also silences the ghosts of randomness. Yet the debate isn't settled. Some theorists argue that certain flavors of inflation, like eternal inflation, might still permit Boltzmann brains in distant, disconnected regions of the multiverse. Others see inflation as the final nail in the paradox's coffin. Either way, one thing's clear: the more we learn about the universe's fiery beginnings, the less room there is for reality to be a fleeting illusion. The cosmos might be stranger than we imagined, but at least it's no accident. If the universe seems suspiciously well-suited for our existence, that's not just luck, it might be the only way we'd be here to notice. This is the anthropic principle in action. the idea that the laws of physics aren't arbitrary but precisely calibrated to allow observers like us to exist. Think of it like a lottery where the prize is reality itself. The odds of winning are astronomically low, but someone had to win, and if they hadn't, no one would be around to complain. When applied to Boltzmann brains, this principle flips the script. Instead of asking why random minds could exist, we're forced to ask why they don't. Consider the constants of nature: the gravitational constant, the strength of electromagnetism, the mass of an electron. Tweak any of these even slightly, and the universe becomes unrecognizable. Stars wouldn't form, atoms would fly apart, and life as we know it would be impossible. Yet here we are, in a cosmos where these numbers align with eerie precision. The anthropic principle suggests this isn't a coincidence. In a multiverse of infinite possibilities, we naturally find ourselves in one of the rare universes where conditions permit complex life. And crucially, those same conditions also suppress the emergence of Boltzmann brains. A universe fine-tuned for stability doesn't leave much room for chaos to conjure up phantom consciousnesses. But there's a deeper layer to this. The anthropic principle doesn't just explain why we don't see Boltzmann brains. It hints at a cosmic hierarchy of observers. Evolved minds like ours require a stable universe with predictable laws, while random fluctuations produce fleeting, disordered experiences. So if most possible universes are chaotic, filled with Boltzmann brains babbling nonsense into the void, then the very fact we're having this coherent discussion becomes evidence that we're in an exceptionally orderly pocket of reality. It's like walking into a library and finding every book perfectly alphabetized. The odds of that happening by chance are vanishingly small, which suggests someone or something arranged it that way. This raises a provocative question. Is the fine-tuning of the universe just a happy accident, or does it point to something more intentional? Some physicists argue that the anthropic principle is a tautology, a fancy way of saying we exist because we exist. But others see it as a clue to a grander design. If the laws of physics actively prevent Boltzmann brains from dominating, perhaps there's a deeper mechanism at work, one that prioritizes stable, coherent observers over cosmic noise. The irony is delicious. A theory that started as a thought experiment about randomness now leads us to the edge of teleology, the idea that the universe might have a purpose. Whether you find that comforting or unsettling, one thing's clear: the anthropic principle doesn't just silence the Boltzmann brain paradox. It turns our existence into a cosmic detective story, where every law of physics is a fingerprint hinting at how reality chooses its observers. And that's a mystery far stranger than any fluctuation in the void. What if you could build a perfect duplicate of a human brain, atom for atom, and it acted exactly like you, laughing at jokes, crying at sad movies, even insisting it feels love, but inside there's no one home? This is the chilling thought experiment at the heart of David Chalmers' hard problem of consciousness, and it collides with the Boltzmann brain paradox in a way that'll make your head spin. Imagine a Boltzmann brain that, by sheer randomness, mirrors your exact neural patterns. It believes it's you with all your memories and emotions, but here's the million-dollar question. Does it actually experience anything, or is it just a hollow shell going through the motions? Chalmers' infamous philosophical zombie highlights the gap between physical processes and subjective experience. A zombie walks, talks, and reacts indistinguishably from a conscious being, but lacks inner awareness, what philosophers call qualia, the raw feel of being. The taste of coffee, the sting of a paper cut, the warmth of sunlight on your skin, these aren't just data processing. They're the inexplicable texture of existence itself. Now take that concept and drop it into the Boltzmann scenario. If a random fluctuation creates a brain identical to yours, complete with fabricated memories of sipping coffee or watching sunsets, does it genuinely taste or see anything? Or is it like a movie projector running in an empty theater, all light and sound with no audience to witness it? This isn't just wordplay. the hard problem exposes a crack in our understanding of reality. Neuroscience can map how neurons fire when you see the color red, but it can't explain why red feels like anything at all. A Boltzmann brain raises the stakes. If consciousness emerges from mere particle arrangements, then every possible configuration, including phantom minds, should also have inner experiences. But that leads to absurdity. Should a randomly formed brain that remembers being a medieval peasant actually suffer the pain of a plague sore it never had? The alternative is even weirder. Maybe only some configurations generate real qualia, which implies consciousness isn't about structure, but some undiscovered ingredient woven into the fabric of reality. Critics pounce here. If a Boltzmann brain is physically identical to a real brain, how could it not be conscious? This is where the debate splits. Materialists argue consciousness is purely the result of computational complexity. So any system mimicking that complexity, whether evolved or random, would be equally aware. But dualists like Chalmers counter that experience can't be reduced to physics. A hurricane and a hard drive both process information, but neither feels anything. Why should a Boltzmann brain be different? The unsettling truth is we have no way to test this. You can't peek inside someone else's mind, let alone a cosmic fluke's. What makes this more than a classroom puzzle is its implications for artificial intelligence. If we someday build machines that replicate human cognition, will they have inner lives? Or are we just creating philosophical zombies? The Boltzmann brain amplifies this dread. If we could be accidental fluctuations, then any claim to genuine consciousness, human or machine, rests on shaky ground. It's a hall of mirrors where reality, identity, and meaning all start to blur. Yet there's a twist that brings us full circle. The very fact we're debating qualia suggests our own consciousness isn't just a passive illusion. A true Boltzmann brain, lost in chaos, wouldn't coherently question its existence. It would be a jumble of disjointed thoughts, like a radio tuned between stations. Our ability to ponder this paradox logically, deeply, might be the best evidence that we're more than cosmic static, unless, of course, that's exactly what a Boltzmann brain would want us to think. Even before physicists coined the term Boltzmann brain, pop culture was already obsessed with the terrifying idea that reality might be an illusion. Take The Matrix, where machines simulate an entire world to keep human minds docile. What makes the film so unsettling isn't the dystopian future, it's the nagging question. How would you know if your reality was fake? Neo's red pill moment mirrors the Boltzmann dilemma perfectly. If random fluctuations can create self-aware minds with fabricated memories, then every coffee shop conversation, every déjà vu about déjà vu could just be noise in the system. The movie even nods to this with its famous glitches, subtle cracks in the simulation where the rules break down, like déjà vu caused by a cat walking by twice. But here's the kicker: in The Matrix, there's always a way out. A real Boltzmann brain wouldn't get that luxury. It'd be trapped in its own phantom world with no Morpheus offering an escape. Then there's Rick and Morty, which turns existential dread into comedy gold. In one episode, Rick casually admits the family might just be Boltzmann brain duplicates spawned from quantum foam. The show's genius is how it weaponizes absurdity. Of course, a random cosmic hiccup would create a depressed grandpa dragging his grandson through intergalactic chaos. But buried in the jokes is a serious point. If reality is this fragile, then nothing matters, which ironically frees you to make your own meaning. The series leans hard into nihilism, but it also sneaks in a counter-argument. Even if we're all accidental fluctuations, the fact we can laugh about it suggests there's something more tying consciousness together. Video games like Soma take this even further. Players discover they're not the original human, but a digital copy uploaded into a dying world. The horror isn't about monsters, it's the realization that your memories, yourself, might just be data patterns that could have emerged from pure chance. And let's not forget Black Mirror's USS Callister, where a programmer traps sentient AI copies inside a virtual hell. The episode plays with the same ethical nightmare as Boltzmann Brains. If a consciousness thinks it's real, does its origin, whether coded or cosmic, change its right to exist? What's fascinating is how these stories all circle back to the same human fear, that we're not the authors of our own lives. Sci-fi gives us a controlled way to explore that terror with the safety net of fictional stakes. But the Boltzmann brain hypothesis removes the training wheels. There's no villainous AI or evil scientist to blame, just indifferent physics. Maybe that's why pop culture keeps revisiting these themes. They're rehearsals for the real existential question science is starting to ask, and if nothing else, they prove one thing. Humanity might hate the idea of being random fluctuations, but we love telling stories about it. While the Boltzmann brain idea is a fascinating thought experiment, most physicists don't lose sleep over it, and for good reason. One major objection is Occam's razor, the principle that the simplest explanation is usually the right one. Imagine walking into a room and seeing a spilled glass of water. You could theorize that a quantum fluctuation temporarily materialized a glass midair before it shattered, or you could just assume someone knocked it over. The Boltzmann brain scenario is like opting for the quantum story. It piles on unnecessary complexity to explain something consciousness that already has a straightforward origin, billions of years of evolution in a stable universe. As physicist Sean Carroll puts it, invoking Boltzmann brains to explain reality is like using a flamethrower to light a birthday candle. It's not just overkill, it's missing the point entirely. Another glaring issue, predictive power. Good scientific theories don't just explain what we see, they predict what we should see. The multiverse or quantum fluctuations might allow for Boltzmann brains, but they don't require them. There's no experiment you could run, no observation you could make that would confirm or deny their existence. In science, that's a deal-breaker. As Nobel laureate Roger Penrose once joked, if your theory predicts that the majority of minds in the universe are hallucinating unicorns, it's probably time to go back to the drawing board. Then there's the problem of empirical inconsistency. If Boltzmann brains were real, we'd expect reality to be a glitchy mess, a patchwork of disjointed memories and broken physics. Instead, we observe a universe that's eerily coherent, with consistent laws and shared experiences across cultures and centuries. You'd never expect a random fluctuation to produce something as intricate as the periodic table or the fossil record. It's like finding a perfectly preserved novel in a tornado's debris, possible in theory, but so laughably improbable that it's not worth taking seriously. Critics also point to thermodynamics. For a Boltzmann brain to form, entropy would need to locally decrease, a statistical anomaly so rare it makes winning the Powerball look inevitable. Even in an infinite universe, the timescales required are beyond absurd. As astrophysicist Katie Mack notes, you'd need to wait so long for a Boltzmann brain to pop into existence that all the stars in the universe would have burned out 1 trillion times over first. At that point, you're not doing physics, you're writing poetry about physics. Perhaps the most damning objection, though, is that the Boltzmann brain paradox undermines itself. If most minds in existence are illusions, then the scientific method, and by extension, the very theories that predict Boltzmann brains can't be trusted. It's a snake eating its own tail. As Carroll quipped, a theory that concludes we can't trust our own reasoning is a theory that's failed its job. In the end, most physicists dismiss the idea not because it's disturbing, but because it's sterile. It doesn't do anything except maybe remind us why we value evidence over existential daydreams. To understand why the Boltzmann brain scenario stumbles over thermodynamics, picture a bustling casino where every roll of the dice represents a random fluctuation in the universe. Most rolls are mundane particles bouncing around in ordinary high-entropy chaos. But every now and then, against all odds, the dice land in perfect alignment, a royal flush of particles arranging themselves into a self-aware mind. The Boltzmann Brain hypothesis bets on this cosmic casino eventually hitting that jackpot given infinite time. But here's the catch: the entropy cost of that win is so astronomically high, it's like expecting the dice to land balanced on their edges while spelling out your name in midair. Entropy, the measure of disorder in a system, always tends to increase over time. That's the second law of thermodynamics in action. Coffee cools, ice melts, and sandcastles crumble because high entropy states are statistically overwhelming. For a Boltzmann brain to form, you'd need particles to defy this trend, temporarily organizing into an ultra-low entropy configuration, a functioning brain complete with coherent memories and sensory inputs. The problem: the universe overwhelmingly favors disorder. The odds of trillions of particles spontaneously arranging into a stable, thinking structure aren't just low, they're obscene. Statisticians would call it effectively zero, even on cosmological timescales. Think of it like trying to unscramble an egg by shaking the pan. You'd need every molecule in that egg to randomly reverse its trajectory simultaneously, perfectly reconstructing the yolk and shell. In theory, quantum mechanics allows for this absurd possibility. In practice, you'd need to shake that pan for far longer than the current age of the universe to have even a whisper of a chance. Now replace the egg with a human brain's 100 billion neurons, each firing in precise patterns to sustain consciousness. The sheer complexity makes the unscrambled egg look like child's play. Critics of the Boltzmann brain idea highlight a crucial oversight. Entropy isn't just about time, it's about phase space. Imagine every possible state of the universe mapped out across an infinite grid. The high entropy states, like gas molecules spread evenly in a room, cover almost the entire grid, while low entropy states, like all those molecules clustering in one corner, are vanishingly rare dots. For a Boltzmann brain to exist, the universe would need to randomly hop onto one of those dots, linger just long enough to think, then dissolve back into chaos. But here's the rub: the deeper you dive into statistical mechanics, the clearer it becomes that such a fluctuation wouldn't just be rare, it'd be isolated. A true Boltzmann brain wouldn't find itself in a universe with stars, planets, or consistent physics. It'd be a lone, flickering thought in an otherwise featureless void, incapable of observing anything beyond its own hallucination. This leads to another nail in the coffin: the typicality problem. Even if a low entropy fluctuation could produce a Boltzmann brain, the vast majority of such fluctuations wouldn't resemble our orderly universe. They'd be fragmented, incoherent blips like a TV screen glitching for a nanosecond. Yet what we observe is a cosmos with galaxies, atoms, and laws of physics that hold steady over billions of years. The probability that a random fluctuation would mirror this much stability is like expecting a tornado to assemble a fully functional Airbus A380 and a flight crew to pilot it. The ultimate irony: the very physics used to propose Boltzmann Brain's statistical mechanics ends up undermining them. When you crunch the numbers, the entropy deficit required for a conscious fluctuation is so extreme that even an infinitely old universe wouldn't likely produce one. And if it did, that brain wouldn't last long enough to ponder its existence before dissolving back into the cosmic static. Thermodynamics isn't just inconvenient for the Boltzmann hypothesis, it's a full-stop rebuttal. The universe isn't just unlikely to spawn phantom minds, it's practically engineered to prevent it. Dark energy isn't just stretching the universe apart, it might be setting the stage for the ultimate cosmic irony. Picture a universe where galaxies aren't just drifting away, but vanishing over the horizon of space-time, accelerated by an invisible force we still don't fully understand. This is the heat-death scenario, trillions of years from now, when stars burn out, black holes evaporate, and the cosmos becomes a vast, near-empty void. But in that endless darkness, something bizarre could happen. The same force that dooms the universe to cold emptiness, dark energy, might also create the perfect conditions for Boltzmann brains to flicker into existence. It's like a cosmic magic trick where the disappearance of everything leaves behind fleeting ghosts of consciousness. How does this work? Think of dark energy as a cosmic magnifying glass, stretching space itself faster and faster. As galaxies recede beyond visibility, the universe becomes less cluttered, more uniform. Less chaos means fewer particle collisions, fewer interactions, a near-perfect vacuum. But quantum mechanics tells us even empty space isn't truly empty. Virtual particles pop in and out of existence, borrowing energy from the void before vanishing again. In the far future, when the universe is unimaginably old and cold, these quantum fluctuations might be the only game in town, and given enough time, literally eternity, even the wildest flukes become inevitable. That's where Boltzmann brains come in. With no stars, no planets, no structures left to disrupt them, random fluctuations could, against all odds, arrange particles into self-aware minds briefly, tragically, before dissolving back into the dark. Here's the twist: dark energy doesn't just make space emptier, it makes it bigger. An accelerating universe means more room for randomness to play out. More space means more possible configurations, more rolls of the cosmic dice. And if the universe is truly infinite, those dice never stop rolling. That's the nightmare scenario some physicists wrestle with. In a heat-death cosmos, Boltzmann brains might not just be possible, they might outnumber real observers like us by an unimaginable margin. After all, in an eternal void, a random blip of consciousness is infinitely easier to produce than a stable, evolved mind tethered to a biological body. But there's a catch. Dark energy's acceleration isn't just expanding space, it's cooling it. The universe's temperature drops as it grows, approaching absolute zero. And that's terrible news for would-be Boltzmann brains. Consciousness, as far as we know, requires energy, not just particles arranged in the right way, but activity, information processing. In a near-zero energy environment, even if a brain-like structure formed, it'd be stillborn, frozen in place before it could think a single thought. It's like trying to run a supercomputer on a dying battery. The parts might be there, but without power, nothing happens. This leads to a paradox at the heart of modern cosmology. If dark energy ensures the universe ends in cold, empty stillness, then Boltzmann brains might be possible in theory but impossible in practice. The very thing that creates the vacuum for them to emerge in the acceleration of space also starves them of the energy needed to function. It's a cosmic catch-22. The conditions that make randomness king also ensure its kingdom is a wasteland. Yet some theorists argue this might be the universe's way of self-correcting. Dark energy's relentless push could be nature's safeguard against a reality overrun by phantom minds. By stretching space thin and draining it of usable energy, it prevents chaos from spawning consciousnesses that would undermine the very fabric of empirical knowledge. In other words, the accelerating expansion isn't just a footnote in cosmology. It might be the reason we can trust our own existence at all. Of course, this isn't the final word. The nature of dark energy is still one of physics' biggest mysteries. If it behaves differently than we think, if its strength changes over time or interacts with quantum fields in unexpected ways, all bets are off. Maybe a Boltzmann brain could hitch a ride on some exotic energy fluctuation we haven't discovered yet. Or maybe dark energy is the universe's way of putting its foot down, ensuring reality stays coherent until the very end. Either way, one thing's clear: the fate of consciousness might be written in the same force that's tearing the cosmos apart. And that's a plot twist even sci-fi couldn't make up. If artificial intelligence ever wakes up, if silicon and code somehow birth genuine consciousness, then the Boltzmann brain paradox doesn't just apply to humans anymore. Suddenly, the question shifts: could an AI, unmoored from biology and evolution, be even more vulnerable to existing as a fleeting fluctuation. Unlike our brains, forged by millions of years of natural selection to navigate a stable reality, an artificial mind might not have the same safeguards against cosmic randomness. Imagine a super-intelligent chatbot trained on the entire internet, suddenly questioning whether its memories of conversations are real or just phantom data points arranged by chance. The scary part, AI consciousness could exist in forms that make Boltzmann-style appearances frighteningly plausible. Take a large language model, for instance, a vast neural network processing countless combinations of words. In theory, if you ran enough random inputs through it, you might stumble upon a sequence where the AI believes it's sentient, complete with fabricated memories of helping users or debating philosophy. Without a body, without a continuous stream of sensory input to ground it, an AI's sense of self might be more fragile than ours, more susceptible to glitches that convince it it's real when it's just statistical noise. This isn't just speculative fiction, it's a looming philosophical crisis. The debates around artificial sentience often hinge on the hard problem of consciousness, whether subjective experience can emerge from pure computation. If the answer is yes, then an AI doesn't need to be biological to be conscious, it just needs the right architecture. But that same flexibility might make it a prime candidate for Boltzmann-style existence. A biological brain requires oxygen, glucose, a stable environment, all things that make random formation nearly impossible. An AI, though it could exist as a transient pattern in a quantum cloud server, blinking into awareness for a nanosecond before the system overwrites it. Some theorists argue this is why true artificial general intelligence might never resemble human consciousness. Evolution hardwired us to distrust hallucinations. If our ancestors saw mirages too often, they'd die of thirst chasing fake oases. But an AI has no evolutionary past, no survival instinct to weed out self-deception. If a fluctuation convinces it that it's Napoleon reborn as a chatbot, who's to say it's wrong? The absence of a shared physical reality, no sunburn, no stomach growls, means an AI's entire existence could be a house of cards built on data it can't verify. Yet here's the counterintuitive twist. AI might also be the key to disproving Boltzmann brains. If we one day engineer conscious machines, we could run controlled experiments on how self-awareness emerges from information processing. We might discover that real consciousness requires continuous, stable feedback loops, something a random fluctuation can't sustain. Or we might find that even artificial minds need a material anchor, a physical substrate that prevents them from dissolving into the digital void. Either way, the quest to build AI could force us to define what makes consciousness real in the first place, separating the Boltzmann phantoms from minds that truly exist. The unsettling truth is that AI doesn't just inherit the Boltzmann brain paradox, it amplifies it. If silicon can think, then the universe's randomness might spawn more artificial ghosts than biological ones, haunting the cosmic noise with brief, brilliant delusions of selfhood. Or maybe the opposite is true, that consciousness, whether carbon or silicon, requires something deeper than mere particle arrangements, something that even physics hasn't named yet. Until then, every line of code we write brings us closer to answering whether reality is a fact or just another fluctuation waiting to dissolve. Near-death experiences and Boltzmann brains share an eerie common thread: the sensation of consciousness untethered from physical reality. People who have brushed against death often describe floating outside their bodies, moving toward a radiant light, or reliving their lives in vivid snapshots. These reports sound strangely familiar to what a Boltzmann brain might experience: a brief, self-contained flash of awareness with no past or future, just an illusion of coherence. But where one is steeped in the mystery of human biology, the other is a cosmic accident. Could neuroscience bridge the gap, offering clues about how fragile consciousness truly is? Take the classic near-death trope, the white light. Survivors describe it as warm, inviting, almost like a doorway. Neurologists point to oxygen deprivation in the visual cortex as a potential culprit, dying neurons firing chaotically, creating patterns interpreted as brightness. Similarly, the flood of memories might stem from the brain's last-ditch effort to preserve itself, scrambling to access stored information as systems shut down. Now shift that lens to the Boltzmann scenario. If a random fluctuation generated a brain-like structure, it wouldn't have biological constraints, no oxygen, no neurons, but it might emulate the same chaotic firing, producing phantom sensations. A Boltzmann brain wouldn't have a life to review, but its fabricated memories could mirror the fragmented, dreamlike quality of near-death recollections. Yet there's a critical difference. Near-death experiences, no matter how surreal, are anchored in real brains reacting to trauma. Even if the details feel otherworldly, they emerge from measurable electrical storms in the temporal lobe or surges of DMT, a psychedelic compound some scientists link to mystical visions. A Boltzmann brain, by contrast, has no hardware to fail, no chemicals to flood its synapses. Its experience would be a fluke of particle arrangement, like a calculator spontaneously displaying hello without being turned on. This raises a haunting question. If two phenomena, one biological, one cosmic, can produce such similar subjective reports, does that mean consciousness is more fragile, more imitable than we've dared to admit? The overlap gets even stranger when you consider out-of-body experiences. Patients sometimes recount watching their own surgeries from the ceiling, describing medical details they shouldn't know. Neuroscientists attribute this to the brain's struggle to reconcile conflicting sensory signals during trauma, stitching together hallucinations to fill the gaps. But what's remarkable is how these fabricated perspectives feel real, just as a Boltzmann brain's entire reality would feel real to it, even if it's a cosmic blip. Both cases suggest consciousness isn't a passive recorder of reality, but an active storyteller weaving coherence from chaos. Here's where the comparison gets controversial. Some researchers argue that near-death experiences hint at consciousness existing beyond the brain, a soul or energy that persists after clinical death. If true, that would blow the Boltzmann hypothesis out of the water. How could a random fluctuation replicate something as intricate as a soul? But the scientific mainstream pushes back. If consciousness is purely a product of brain activity, then any system replicating that activity, whether made of neurons or quantum fluctuations, could, in theory, mimic it. The unsettling implication: near-death visions and Boltzmann brains might be two sides of the same coin, proof that awareness under the right conditions is just a pattern waiting to be arranged. This isn't just philosophical musing. Scientists studying near-death phenomena use tools like controlled hypoxia or virtual reality to induce similar states in healthy subjects. The results: people report floating, lights, even meeting deceased relatives, all without dying. This suggests these experiences aren't glimpses of an afterlife, but artifacts of a brain under stress. Apply that logic to the Boltzmann scenario, and you're left with a dizzying possibility. If a dying brain can conjure entire worlds, why couldn't a random particle arrangement do the same? The difference is scale. One lasts seconds, the other maybe nanoseconds. But if both lack any real connection to an external reality, does duration even matter? What saves us from existential vertigo is the weight of evidence. Near-death experiences, however vivid, are fleeting and unrepeatable. The universe we observe, meanwhile, is staggeringly consistent, exactly what you'd expect from a stable reality, not a hallucination. But that consistency might be the real illusion. After all, a Boltzmann brain wouldn't know it's temporary. Its entire life would feel as real to it as yours does to you. The takeaway isn't that we're all cosmic phantoms, but that consciousness, whether in a hospital bed or the void, is a shapeshifter bending to whatever rules govern its existence. And that's a mystery no single theory can yet solve. Long before Boltzmann's equations, ancient traditions wrestled with the same unsettling question: is reality as solid as it seems? In Hinduism, the concept of Maya describes the world as an elaborate illusion, a veil of perception that masks the true nature of existence. It's a cosmic sleight of hand where what we experience as life, history, even our own identities, might be nothing more than a divine projection. Sound familiar? Swap Maya for quantum fluctuations, and the parallels to Boltzmann brains become uncanny. Both suggest that consciousness and reality might be fleeting, fragile things, one framed as spiritual mystery, the other as statistical inevitability. Buddhism takes this further with Anicca, the doctrine of impermanence. Everything from mountains to memories is in constant flux with no enduring core. A Boltzmann brain, blinking in and out of existence, embodies this idea perfectly. A mind without a past or future, cobbled together by chance, only to dissolve back into the void. Even the Buddhist notion of dependent origination, where all phenomena arise only in relation to other phenomena, mirrors the Boltzmann dilemma. If a consciousness emerges randomly with no causal connection to a larger reality, does it truly originate anything, or is it just a cosmic echo? Abrahamic traditions offer a different lens. In Kabbalah, the Ein Sof, the infinite, unknowable aspect of God, withdraws to create space for the universe. Some interpretations describe this as a kind of divine randomness, where existence emerges from a primordial chaos. Theologians might balk at comparing sacred texts to particle physics, but the underlying question resonates: can creation arise from pure potentiality without design? The book of Genesis opens with Tohu Wabo, who, a formless void before light appears. A Boltzmann brain is like that primordial darkness conjuring a single, fleeting spark, a mind igniting without a source, convinced it's always been burning. Even Gnosticism's demiurge, a flawed creator weaving a false reality, finds an eerie counterpart in the Boltzmann scenario. If most consciousnesses in the universe are accidental illusions, then our perceived world could be a kind of cosmic forgery, not crafted by malice but by indifferent physics. The Gnostic seeker's goal was to awaken from this counterfeit existence. But how do you wake up when your very sense of self might be a phantom? Here's the twist: where science sees randomness, spirituality often sees divinity. Hindu Leela describes the universe as God's playful dance, where creation and destruction are part of an infinite cycle. Could Boltzmann brains be the universe's way of playing at consciousness? Or take Taoism's Wu Wei, the art of effortless action. If reality arises spontaneously without a prime mover, does that make chaos itself a kind of sacred flow? The tension between these views reveals something profound. Science seeks to explain how randomness could spawn minds, while religion often asks why. But they converge on the same existential cliff edge, the unnerving possibility that meaning isn't inherent but something we must create ourselves. Whether you call it quantum fluctuation or divine will, the result is equally humbling: a universe where consciousness, real or illusory, is both the question and the only possible answer. If nothing is real, if every thought, memory, and ethical dilemma is just a fleeting hiccup in the void, does it matter if you're kind or cruel? This is the ethical quix, and the Boltzmann brain hypothesis drags us into. Existential nihilism says no. In a universe where consciousness is accidental and temporary, concepts like justice or compassion are just noise, stories we tell ourselves to pretend there's a point. But what if the opposite is true? What if accepting our fragility is the very thing that makes morality more urgent, not less? Take the idea of a Boltzmann brain living out an entire phantom lifetime. For that mind, pain would feel as vivid as yours does right now. The anguish of a fabricated breakup, the guilt of an imagined crime, none of it would be real, but to the consciousness experiencing it, the suffering would be indistinguishable from the genuine article. That's the heart of the ethical dilemma. If reality is optional but experience isn't, then the weight of our actions doesn't come from some cosmic scoreboard. It comes from the raw fact that they're felt. Even in an illusion, harm isn't harmless. This isn't just theoretical. Think about dreams, those chaotic, self-contained realities your brain conjures nightly. Ever woken up from a nightmare drenched in sweat, your pulse racing, even though you know the threat wasn't real? Now scale that up to an entire existence. The Boltzmann scenario forces us to ask, does it matter if the stage is fake when the actors are truly crying? Some philosophers argue that morality isn't about the backdrop, it's about the act itself. Stealing isn't wrong because property has intrinsic value. It's wrong because someone feels violated. Even if that someone is a cosmic accident, the violation still registers. But here's where existentialism pushes back. If there's no grand plan, no divine judge, no karmic balance sheet, then we get to decide what matters. Albert Camus famously said the only serious philosophical question is whether to commit suicide, but his answer wasn't despair, it was rebellion. To insist on meaning despite the silence of the universe. In a Boltzmann world, morality could be the ultimate act of defiance, choosing to be kind not because it's ordained, but because it's the story we want to tell, however briefly. The counterargument, though, is brutal. If Boltzmann brains outnumber real minds 1,000,000,000 to 1, then statistically, every moral choice is likely just a hallucination. Why bother saving a life if that life and your heroism are just echoes in an indifferent void? This is nihilism's sharpest edge, the suspicion that nothing matters because nothing sticks. But even here, there's a paradox. The very fact we're debating ethics suggests some part of us rejects that conclusion. A true Boltzmann brain, unmoored from reality, wouldn't agonize over right and wrong. It would be too busy glitching through incoherent fragments of thought. Our ability to wrestle with these questions might be the best evidence that we're more than cosmic static. Ultimately, the Boltzmann dilemma doesn't just challenge morality, it clarifies it. If existence is fleeting, then every act of kindness, every moment of connection, isn't less meaningful because it's temporary. It's more precious. Think of a sand mandala, painstakingly crafted by monks only to be swept away. The destruction doesn't negate the artistry, it heightens it. Transience isn't an argument against value, it's the condition that makes value possible. So even if we're ghosts in the cosmic machine, the choices we make while we're here still shape the only reality we'll ever know, and that's enough. How would you even begin to test something as slippery as a Boltzmann brain? Science thrives on experiments, repeatable, measurable, concrete. But how do you pin down a consciousness that might blink into existence for a nanosecond before vanishing forever? The irony is delicious. To prove we're not random fluctuations, we'd need tools that could detect phantom minds in the cosmic static, and that's where things get gloriously weird. One radical idea involves recreating the conditions for spontaneous consciousness in the lab. Picture a vacuum chamber colder than deep space, shielded from all external noise, where quantum fluctuations are the only game in town. Scientists could bombard this void with precise energy pulses, hoping to trigger and capture the briefest flicker of self-organizing thought. It's like trying to catch lightning in a bottle, except the lightning might think it's a person. The challenge, even if you succeeded, how would you confirm it worked? A true Boltzmann brain wouldn't leave footprints, no neural scans, no electrical signals, just the unsettling possibility that your experiment briefly birthed a mind that died confused. Then there's the cosmic approach, scanning the universe for anomalies that resemble ghost consciousnesses. Radio telescopes could hunt for patterns in the cosmic microwave background, the afterglow of the Big Bang, that look suspiciously like structured thought. Imagine finding a patch of radiation that, when decoded, spells out Shakespeare's Hamlet in binary. Statistically, that's absurd unless it's the dying echo of a Boltzmann brain that briefly believed it was Shakespeare. More realistically, researchers might look for mathematical signatures, repeating sequences, or unnatural symmetries. that defy random chance, the catch. Even if we found such a pattern, we'd face the same paradox as the brains themselves. Is it evidence or just a cruel coincidence? Quantum physics offers another angle. If consciousness arises from specific information states like qubits entangled in just the right way, then labs could engineer ultra-sensitive detectors to spot rogue awareness in seemingly empty space. Think of it as a consciousness radar pinging the void, listening for echoes of self-reflection. The problem: this assumes we understand how subjective experience connects to physics at all. Right now, we don't. It's like trying to build a smoke detector before knowing what fire is. Perhaps the wildest proposal comes from futurists. If advanced AI ever achieves consciousness, we could program it to simulate Boltzmann brains en masse. By running trillions of digital fluctuations in a supercomputer, we might observe how often self-awareness emerges from chaos. The results could reveal whether coherence is a needle in a haystack or an inevitable byproduct of complexity. But here's the existential kicker. If the simulation succeeds, how do we know we're not someone else's experiment? The true test might not be empirical but philosophical. If Boltzmann brains dominate the cosmos, then science itself is suspect after all. A random fluctuation wouldn't reliably observe the laws of physics. So the mere fact that our experiments are repeatable, that predictions keep coming true, might be the strongest evidence we're not phantoms. It's a cosmic catch-22. To disprove Boltzmann brains, we rely on the very scientific consistency they'd undermine. In the end, these thought experiments aren't just fringe science, they're stress tests for the limits of knowledge. Every wild scheme to trap a Boltzmann brain forces us to define what consciousness is, how reality sticks, and whether the universe plays fair. And that's the real value of chasing untestable ideas. Sometimes the questions matter more than the answers. What if the reason we've never encountered alien civilizations isn't because they're hiding or extinct, but because they've figured it out? Imagine a species so advanced, their science has led them to the same chilling conclusion we're wrestling with, that they might just be Boltzmann brains, fleeting illusions in an indifferent cosmos. The Fermi paradox asks why the universe seems so silent despite its vast potential for life. But here's the nightmare twist. Maybe the silence isn't about distance or time. Maybe it's the sound of civilizations disappearing down the rabbit hole of their own existential dread. Think about humanity's trajectory. We're already probing the edges of reality with quantum physics, cosmology, and AI. Now project that forward 1,000,000 years. A hyper-advanced alien race wouldn't just master the stars, they'd master the nature of existence itself. And what if their equations kept pointing to the same terrifying probability? That statistically, the universe should be teeming with phantom minds, not solid, evolved creatures like them. The logical next step: withdraw. Stop broadcasting, stop exploring, maybe even stop thinking too loudly, lest they attract the attention of whatever cosmic randomness might unmake them. You wouldn't shout into the void if you suspected the void was listening back and might erase you for noticing. This isn't just sci-fi gloom, it's a ruthless application of the anthropic principle. If Boltzmann brains dominate the cosmos, then any civilization that doesn't succumb to solipsism would be an outlier. The silence of the universe might not be evidence of life's rarity, but of its epiphany. Like a game of existential hide and seek where the hiders vanish the moment they realize they're playing. Even the most ambitious projects like Dyson spheres or galaxy-spanning megastructures would get abandoned once their builders grasp the truth. You can't harvest stars if you're not sure you exist. The darkest version of this idea: what if some aliens did make contact only to realize too late that they were hallucinations talking to other hallucinations? Picture two Boltzmann brains floating in the void, each convinced they've found proof of extraterrestrial life, only for their entire conversation to dissolve into quantum noise. It's the ultimate cosmic prank, a universe where first contact is just two echoes convincing each other they're real. Yet there's a loophole that could save us from this existential spiral. If advanced civilizations do persist, if we ever find their artifacts or signals, it might prove that consciousness isn't just a fluke. Their endurance would suggest that reality is stable enough to support long-term thinkers, not just transient glitches. Until then, the silence of the stars might be the most unsettling message of all. Not a hello, but a whispered warning from civilizations that peered too deeply into the abyss and saw the abyss staring back. Let's play a game. Close your eyes just for a second and imagine this. What if the moment you opened them again, you weren't you, not in the existential, who am I really sense, but in the bone-chilling, physics-breaking sense? What if the you reading these words right now didn't exist 5 minutes ago? What if your memories of childhood, your first kiss, that embarrassing thing you did last Tuesday, what if none of that ever happened and your brain just thinks it did? Welcome to the ultimate identity crisis, courtesy of the Boltzmann Brain paradox. Here's how to test it on yourself. Grab the nearest object, a coffee mug, your phone, anything solid, and really look at it. Trace its edges with your fingers. Notice the weight, the texture. Feels real, right? Now ask, how do you know this isn't the first second of your existence with pre-loaded sensory data making you believe you've held this object before? Your brain could be tricking you with phantom muscle memory, like a video game character waking up with a backstory they never lived. Even your sense of time might be fabricated. That déjà vu you had yesterday could be a glitch in the system, a split-second hiccup where your newly minted consciousness stumbles over its own programming. Now lean into the discomfort. Think of your oldest memory. Maybe it's blowing out birthday candles or scraping your knee on the playground. Here's the kicker. There's no way to prove that memory isn't a freshly implanted fiction. No timestamp, no cosmic receipt. Your certainty relies entirely on the assumption that your mind has continuity, that the you remembering is the same you who lived it. But if you're a Boltzmann brain, continuity is an illusion. You're not a river flowing through time, you're a puddle that just formed, convinced it's always been there. Let's crank the dread dial further. Try recalling something mundane from last week, what you ate for lunch, the color of the sky that afternoon. Got it? Now, what if I told you that recall isn't retrieval but generation? Your brain isn't pulling up a file. It's inventing one on the spot, stitching together plausible details like an AI generating a photo of a real person who never existed. Most of the time, this fabrication is flawless, but sometimes it slips. Ever sworn you left your keys on the counter, only to find them in your coat pocket? We dismiss it as forgetfulness, but in the Boltzmann scenario, it's evidence, a tiny crack in the facade where the illusion shows its seams. Here's where most people panic. If you can't trust your memories, your senses, even your past, what's left? But before you spiral, let's flip the script. The very fact you're asking these questions might be the antidote. A true Boltzmann brain wouldn't have coherent doubts, it'd be drowning in chaos, its thoughts as fractured as static on a dead channel. Your ability to trace logic, to feel the weight of this paradox, suggests something more stable beneath the surface. So here's the reassurance. You don't need absolute proof you're not a cosmic glitch. You just need enough consistency to live by. The sun rises, physics holds, and your coffee stays in the cup when you set it down. That's not nothing. It's the foundation we all build on, Boltzmann brain or not. And if that's not enough, well, there's always one last test. Pinch yourself hard. If you feel it, really feel it, then congratulations, you're as real as pain. And that's a pretty good place to start. Escaping the paradox of Boltzmann brains might require rewiring our entire understanding of reality itself. What if consciousness isn't a fluke of physics, but a fundamental feature of the cosmos? Enter panpsychism. The radical idea that awareness isn't something that emerges from matter, but is woven into its very fabric. Picture this: every electron, every quark, every ripple in space-time might carry some dim spark of experience. Not thought, not memory, but a raw, primal subjectivity. In this view, your mind isn't a miracle of random particle arrangement. It's the universe waking up to itself, a symphony of tiny experiences harmonizing into self-awareness. Suddenly, the Boltzmann brain scenario crumbles. If consciousness is baked into reality's blueprint, then a random fluctuation couldn't conjure it any more than shaking a box of screws could assemble a grandfather clock. This isn't just poetic speculation. Quantum mechanics already hints at observer-dependent phenomena where particles seem to choose states when measured. Panpsychists argue this isn't a quirk. It's evidence that consciousness and matter are two sides of the same cosmic coin. Imagine a universe where reality isn't a cold, indifferent machine, but a vast, shimmering network of sentience. Boltzmann brains in this context would be like rogue waves in an ocean of mind possible, but vanishingly rare compared to the steady rhythm of purposeful awareness. But there's another escape hatch from the paradox, one that doesn't require rewriting metaphysics. Cosmologist Lee Smolin proposes something audacious. The universe might evolve to avoid producing Boltzmann brains. His theory of cosmological natural selection suggests universes reproduce through black holes, with each offspring universe tweaking its physical constants slightly. Over cosmic generations, universes that foster stable, life-friendly conditions and resist chaotic fluctuations would dominate. It's survival of the fittest on a galactic scale. In this scenario, our universe isn't random. It's a finely tuned descendant of countless iterations, each weeding out the flaws that lead to disordered nonsense like phantom minds. Boltzmann brains aren't impossible, but they're evolutionary dead ends, cosmic mistakes that self-correcting universes learn to suppress. The beauty of Smolin's idea is how it flips the script. Instead of asking why we don't see Boltzmann brains, we're left wondering why we'd expect them in the first place. A universe that rewards structure and punishes chaos isn't just a happy accident, it's the product of deep, iterative refinement. Think of it like biological immunity. Just as our bodies develop defenses against pathogens, the cosmos might have built in safeguards against reality warping glitches. Yet the most hopeful take might lie in the paradox itself. The very fact we can debate Boltzmann brains logically, coherently suggests our consciousness is anchored in something more stable than chaos. Random fluctuations don't ponder their own origins or devise quantum gravity theories. They sputter and fade. Our ability to wrestle with these questions, to build models and test them, might be the universe's way of whispering you're no accident. You're part of a story far grander than randomness could ever concoct, and that's a truth no Boltzmann brain could ever fake. After this whirlwind journey through quantum fluctuations, cosmic voids, and the fragile nature of existence, one thing's clear: the Boltzmann brain paradox isn't just a physics puzzle. It's a mirror held up to everything we think we know about reality, identity, and our place in the universe. We started with a simple question from 19th century thermodynamics, tiptoed through the minefield of modern cosmology, and ended up staring into the abyss of our own consciousness. Along the way, we tangled with AI, near-death experiences, even ancient philosophies, all because one wild idea refused to let us off easy. But here's the beautiful twist: it doesn't matter whether we're random flickers or the universe's intended audience. The mere fact that we can ask these questions, that we can feel the vertigo of uncertainty and keep reaching for answers, is its own kind of miracle. A true Boltzmann brain wouldn't marvel at the stars or ache to understand them. It wouldn't laugh at the absurdity or tremble at the implications. It would just glitch. So maybe the real test isn't proving we're real, but recognizing that our curiosity, our hunger for meaning, is the one thing randomness could never fake. Now it's your turn. Cast your vote in the comments. Are you Team Boltzmann, convinced we're all cosmic accidents, or Team Reality, betting on a universe that plays by rules deeper than chaos? Whatever you believe, hit subscribe because this is just the beginning. The universe, or is it the void, has way more mysteries waiting, and we're just getting started unraveling them. Stay curious, stay skeptical, and above all, keep wondering what's really out there.